Before we begin today's lesson, a video lesson, I just want to remind you that you should watch and complete the Ed puzzle on triangle inequality before you watch this video. This will make what I say make a little more sense, and also I'm going to kind of go quickly through the triangle inequality since you've already seen the video on it. The other part of your homework is IXL 7.w.4. It is linked in the classwork assignment, so don't forget to do those too. They will be your 20 points for today's classwork. All right, today we are talking about properties of triangles, and before we begin, I just want to talk about classifying triangles by their sides. All right, and that didn't go well. Okay, so we have these three triangles right here. The first triangle, if we're classifying by sides, we're looking at just their sides, not their angles. Yes, this does appear to be an obtuse triangle, but we're not asking about the angles, we're asking about the sides. So you'll see this is labeled as A, B, and B. Sometimes you'll see triangles like that. Sometimes you'll see them in a different form, which I'll talk about right in a second. But the fact that this is A, B, and B means that these two sides must be the same because they use the same letter. Now, another way that you could see this is, remember we talked about tick marks. If these two sides look like this, and this side has two tick marks, that means that any side with one tick mark is the same length, okay? Either way, it's an isosceles triangle because isosceles triangles have two sides that are the same length. All right. Now, for the second one, we see we have A, B, and C. So all three sides are a different length. This could be, with the tick marks, could be 1, 2, and then 3 tick marks, something like that. They mean the same thing. And a triangle with no sides that are the same is called scalene. And finally, we have this triangle that has sides S, S, and S. Sometimes it would look like this with one tick mark in each side. It means that all the sides are the same length, and any triangle with the same length side is called equilateral. Okay, equal for equal and lateral for side. All right. Quickly reviewing the triangle inequality theorem that you just watched and completed a video on. Remember that any triangle, the sum of any two sides must be greater than the length of the third side. That doesn't mean that you have to, in the beginning of the video, she added up all of the different possibilities and checked it. But really all we care about are take the two smallest sides and add them and check that it is larger than the third side, or the largest side. Okay? Now, key here is larger. All right? It cannot be equal to. Even if it's equal to, it doesn't work. If we look at this, which I thought was a really nice way of her showing it when she had that little, whatever that program was, these two sides won't be able to connect because there'll be a whatever, if this is inches, there'll be a 1 inch gap between them. Even if this side was 3, 4 plus 3 adds to 7, but in order for them to touch, they would have to fall all the way down onto this line, and therefore it wouldn't be a triangle because the lines would be overlapping. Okay, so just really quickly, all you have to do is take the two smallest sides. So here, the two smallest are 9 and 4. 9 plus 4 equals 13. 13 is larger than 11, therefore that can be a triangle. 6 feet, 3 feet, 10 feet. The two smallest sides are 6 feet and 3 feet. 6 plus 3 equals 9. 9 is not larger than 10, therefore this could not be a triangle. It's as simple as that. We don't need to spend too much time with it. What you just have to do, take the two smallest sides, 4, 7. 4 plus 7 equals 11. 11 is not greater than 14. Therefore, this could not be a triangle. Two small sides, 9 and 6. 9 plus 6 equals 15. 15 is larger than 10, so yes, this could be a triangle. Two small sides, 10 plus 15, they add up to 25. 25 is greater than 20. Therefore, yes, this could also be a triangle. Now, I'm going to come up with one really quickly and just show you something that the video didn't talk about. If you had 3 and 8 and 11, the two smallest sides, 3 plus 8 equals 11. Is 11 greater than 11? The answer is no, it's not. So that could not be a triangle either. Okay? All right, moving on. Triangle sum theorem. The triangle sum theorem, and again, you should be taking notes on this as well as when you had the Ed puzzle video, okay? The triangle sum theorem states that the angle measures of a triangle will add to 180 degrees. Triangles are very special, but one of the things that they start is this triangle sum theorem, which states that if you add up all of the interior angles of a triangle, it must equal 180 degrees. So here we have 58, 43, and 79. And if we add 58, 43, and 79, we get 180. Okay? If we had something with algebra, if we had one angle that was R, one that was T, and one that was S, what we do know, we may not know what each angle is, but we know that R plus S plus T must equal 180 degrees. And one activity that I used to like to do in the classroom, but you can do it at home if you feel so inclined, is to take a piece of paper and cut a triangle. Any triangle, doesn't matter. It could be obtuse, it could be it could be acute, it could be a right triangle. It doesn't matter what kind of triangle it is. Just cut a piece of paper into a triangle, and if you tear off the corners and piece them together, they will form a straight line, proving that this angle plus this angle plus this angle must be 180 degrees. Okay? And like I said, you can do it over and over and over again. You can do it all day if you want. They will always match up to make a straight line. All right. So how can that help us? Well, what we can do is, what that means, we only need to know two of the sides and we can find the third. For instance, if we know this side is 42 and this side is 63, we don't know this side, but we do know that the three sides add to 180. So we know that 63 plus 42 plus this unknown side equals 180, and then we can use algebra to solve this. 63 plus 42 is 105. 105 plus x equals 180. We subtract 105 from each side, and we find out that that missing angle must be 75 degrees. Here, we do know two angles. We know this is 37, and we know this is 90, because it's the right angle. Okay? So we know that this must be 90 degrees. So we're going to do 37 plus 90 plus y equals 180, which means 37 plus 90 adds to 127. Plus y equals 180, subtract 127 from both sides, and we find out that the missing side here is 53 degrees. So if we want to practice this, here we're going to do 44 plus 79 plus x equals 180. And now we have 123 plus x equals 180. We subtract 123 from both sides, and we get x equals 57. For number 20, we have 34 plus 34 plus y equals 180. 34 plus 34 is 68 plus y equals 180. Subtract 68 from both sides, and we get y equals 112. That means that this angle is 112 degrees. Finally, number 21, we have 29 plus 121 plus w equals 180. 29 plus 121 is 150 plus w equals 180. We subtract 150 from both sides and we get w equals 30. It means that this missing angle is 30 degrees. Okay? All right. Now, here, again, this is 90. So we're going to have 32 plus 90 plus s. And we know that those three angles add to 180. So now we have 122 plus s equals 180. Subtract 122 from both sides, and we find that s equals 58 degrees. I'm not going to go through this one, but I will tell you that t equals 115. If you want to try that, make sure that you get the same answer. Okay, but I do want to get to this one. And now I said we need 2 of the 3 sides to find the third. Here we're missing 2 sides, but we know that 36 plus m equals 180. This is still an algebraic equation that we can solve because the m and the m are like terms. So m plus m is 2m. So it's 36 plus 2m equals 180. We still only have one variable because it's the same variable. We subtract 36 from both sides to give us 2m equals 144. We divide both sides by 2, and we find that m equals 72 degrees. That means that this must be 72 degrees, this must be 72 degrees, and the triangles have a relationship between their sides and their angles. So this is actually, because these two angles are the same, it makes this an isosceles triangle, but that's not what we're looking for. It's just a nice little thing to make a connection with. Finally, the last thing I want to talk about before I let you go on and do the IXL is equilateral triangles. Equilateral triangles are extraordinarily special. Not only do equilateral triangles have the same size sides or the same length sides, but their angles are also the same. So we do know that any equilateral triangle, they have all 3 sides are the same. But we also know that equilateral triangles that have the same sides have the same angles. So if in this case it's W plus W plus W equals 180, 3W equals 180, divide both sides by 3, and we get W equals 60 degrees. So here comes an important note. Equilateral triangles always have 3 60-degree angles. Their angles are always 60 degrees. 60 degrees, 60 degrees, 60 degrees, it adds up to 180. So if you know that it's an equilateral triangle, you know that it adds up to 180 degrees. Okay? So you also, you know that each angle is 60 degrees. Doesn't matter if it's an equilateral triangle that's this big or an equilateral triangle that's this big. They're all going to be 60 degrees, 60 degrees, 60 degrees. This is going to be 60 degrees, 60 degrees, 60 degrees in each angle. Okay? Equilateral triangles always have 3 equal 60-degree angles. And that is today's lesson. So don't forget to hit like like and subscribe to my YouTube channel because we have videos every week. But have a great day, and if you need any help, email me. Good luck.